All right. For the next presentation, we will see why scan-only systems are not enough and how we can employ agentic AI to do better scanning for vulnerabilities. Darius and Catalin will present for us, and that's it. Break a leg.
Thank you for the intro. Hello, everybody. Thank you so much for being with us today. I know that we are one of the last presentations, but it's going to be a blast, so bear with us for the next 45 minutes. You already know the topic, so I'm Catalin Neacsu. I've been in the security industry for more than 15 years with expertise in security operations, threat intel, forensics, and recently, as many of you probably in the room here today, I've been diving into agentic AI workflows and using AI for security monitoring and response. I'm going to let my colleague introduce himself.
Hello, everyone. My name is Darius, and I'm a lead solutions architect at Arcana AI. What we do is basically we design and deploy decision models for security alerts predictions and also agentic workflows at scale for lots of different companies around the world. My background is in cybersecurity operations and automation. Nice to meet you, and looking forward to present.
All right, so this is the agenda. We're going to start by looking at vulnerability management and why threat intelligence information and external information is important in VM. We're going to be talking about, as you already know, agentic AI workflows and decision-making using machine learning and the integration between NoSintel and Arcana platforms. Now, our vulnerability scanner says we're clean. And I'm seeing some smiles in the room here because I feel that many of you have heard this sentence as well, and it kind of ticks me off a bit because many organizations kind of rely on vulnerability scanning solely for attack surface management. I'm here to argue that there are other exposures not available on the network perimeter outside of your network that pose a similar threat to direct vulnerabilities in your organization. So a company's attack surface do expand outside of the network perimeter, and if your strategy ends with vulnerability management and scanning, you might be operating in a false comfort zone. Scanners typically, no CVEs doesn't necessarily mean no exposures, right? Scanners may lack context. They lack real-time threat intelligence information about what campaigns are ongoing, what threat actors do these days, what vulnerabilities are they focused on, if there is a POC exploit code out there. All of that information, all of that contextual information is very relevant for vulnerability management. I'm going to provoke you to a small challenge here. Just think about it. How many days does it take for your vulnerability scanner to provide a signature for a vulnerability that is released today? How many days? Is it 1 day, 2 days, 3 days? Just look at that and look at how fast threat actors might be moving, because threat actors might be developing an exploit faster than your vulnerability scanner deploys a signature. So you might not even know there's a vulnerability out there. And threat actors are constantly mapping organizations, right? There's internet noise, and they not always abide by the same code of ethics that we as security defenders do. They often use leaked data, acquiring that from a dark web post, from a dark web marketplace, or just some Telegram channels. And they take any opportunities they get to get an initial foothold within a victim organization. I put in here statistics coming from 2024 Verizon report where stolen credentials still remains the attacker's top entry point, accounting for 24% of initial entry vectors. And it's not the most correct balance, right? Security defenders need to be perfect every time, whereas an attacker needs only one vulnerability to get their foot in the door. So we do need to start to think about, as an adversary, as an attacker, we need to put our black hats on when we are defending our organizations. And blind spots can easily compose into business risk, right? Unseen means unsafe. And the parallel I'm going to make here is like the law. Not knowing the law does not absolve you from not abiding to it. It's the same thing here. If you are not seeing a threat, that does not absolve your organization from being affected by the specific threat. So visibility is, and information is gold. Now, this is where I introduced Griffin, NoSQL Griffin SaaS platform. It's a project that is quite ambitious, that is trying to bring visibility from different angles, from different security domains, from vulnerability scanning and digital exposure to deep dark web, threat intelligence monitoring, GitHub repositories monitoring. It's all a bundling just to give the right insights and threat intelligence information. It unifies all these areas and transform them in actionable insights for security defenders. And of course, to make it even easier, to make it a PAL, a cybersecurity PAL, right, for you, it has a built-in chatbot through which you can have conversations with your own data, and we're going to look at that a bit later. It uses large language models, of course, RAG and MCP technology. And since I mentioned it, probably the majority of you already know what RAG and MCP is, so sorry for the 1 minute boredom there. RAG is retrieval augmented generation. You know, one of the limitations of LLMs is that they have context with the information they've been trained with. Now, if you want it to have side knowledge, you can hook it up with a vector DB where you store your own context in vectorized shape. And then when you ask an LLM a question, it goes, fetches the extra side information and provides you a more accurate response. MCP, it was released by Anthropic last year. It's part of agentic AI workflows, right? It was the next big thing in AI world, giving LLMs access to tools, access to execute actions, access to run API queries, access to conduct specific actions. So the architecture contains an MCP server and an MCP tool, and the LLM decides which one to execute. And I mentioned the two because Griffin platform leverages both technologies in a different shape. It uses RAG for the information it collected from the various places for your organization. From the dark web, from vulnerability scanning, the most relevant findings are vectorized and stored in the database. And then you can ask questions, right? What do you think about that? What is the biggest risk to my organization? You can see probably on the screen a bit of Griffin wisdom, right? There isn't a threat out there that cannot be solved by a policy or maybe a meeting. And the second type of query is structured. It uses a built-in MCP client-server architecture and launches API questions, API lookups within itself, and then processes the data and presents back the data to you, right? So we are talking a lot about detection, visibility, gaining access to information. We, as security defenders, are already overwhelmed, right? So what I'm proposing is yet another tool, yet another bit in the bucket. So having information isn't necessarily the solution. The trick comes into making decisions, right? What should I do about a particular threat? Can AI solve the question? Well, I think Darius is more entitled to answer the question. So I think this is where Arcana AI comes in. So I'm going to hand it over to Darius for the next slides.
Thank you, Catalin. To start discussing about decision-making in security operations, I'll have to present you a bit Arcana. Arcana AI is a platform where we allow subject matter experts to train their own neural networks, which act as decision models. So that means if you're in a SOC, that could be the security analyst, or the engineer, or the threat hunter. Whoever knows the data best should train those models. Now, these are not LLMs, what we're having there. We did AI before ChatGPT was cool. So these are deep neural networks, which you train on the spot in your company, on your data, and it's only your training that goes into it. It doesn't have any other bias. And because of that, the teams we work with ended up trusting these models to make decisions, something you cannot expect out of an LLM. So next, if we look, let's say, at a more end-to-end workflow, we would have a platform that does the detection, right? looks into the different data sources, has some rules, has some enrichments, and they generate alerts or findings. Now, these findings normally go to a human for analysis and for an initial decision. Well, instead, if we try to do it with Arcana's decision models, we would instead send it to those models. Those models will make a prediction, and then we can act on that prediction by making use, this time, of LLMs through agentic workflows. So just drilling down on that point again, LLMs are great at helping you gather data, are great at reporting, doing custom reporting for you, but decision-making should be done with something else. Ideally with a human, but if there's not enough capacity, this is one potential solution. Now, to show you kind of what I'll be going through in the demo, we have some vulnerability findings from NoSintel going to our decision model. The decision model will tell us if it should perform additional investigation because it's not clear, or whether or not we should archive it because it's not really important for the current situation, or a specific response based on that vulnerability or that finding. Now, that initial decision will trigger different agentic workflows that will do different actions. And at the end, we'll get a report of what was done. Before I jump into that part of the demo, I'll hand it back over to Catalin to show you how things are going in NoSintel.
All right, thanks. So we're going to have two quick demos. The first one is going to be about NoSintel platform, right? So the first quick demo is going to be about NoSintel, right? And the information that is detected, the signals that NoSintel platform generates. So this is just the dashboard. I mentioned that the platform has visibility into various places, vulnerability, deep dark web, etc. And I'm not going to do a full-blown demo of the platform. I just wanted to go into the chatbot application since I kind of referenced it, and it makes sense in the agentic AI world. So the question that I'm going to ask Griffin is, before asking the questions, there are three options to run a question in Griffin. The structured data, this is the MCP way. It runs API requests in the backend, brings the data, interprets LLM, and then surfaces the data. Whereas the conversational is RAG-based query. So we're going to do a RAG-based query first. It's going to take a bit of a while because the information is, after being extracted from the RAG database, is being processed through various agents to make sure that the answer follows specific patterns. And you're always going to see the RAG chatbot answering with an executive summary. Right, so in my particular case, the chatbot recognized that the biggest risk to my organization from all the information that it's collected, it's in some API keys exposure. But I don't know where those API keys, right? So I can ask it, well, give me more information. Which host exposed the API keys? I want to know more. Right, and then it fetched the data, processed it, went through the round of summarization critique agents, and then it gave me the information. It gave me information about the particular exposure. Now let me try the MCP route too. Right, so from query mode, I went to structured data. And through structured data, I can ask the question like this. Let's see if it plays nice with me. I just want to point out something. One of the limitations of LLM is that they are not, and we all know, they are not deterministic, right? You cannot necessarily always expect the exact same answer. This is where decision-making doesn't need to rely on LLM, and you need to look elsewhere, right? So let's see if it plays safe with me today. So now I launched an MCP-based question, meaning that the first step is that this question is transmitted to the LLM. It then looks at the available tools, which is the right API call to, it determines which is the right API call. It processes the API call, and then it launches the query. And The data is not presented, but it summarizes the data based on the provided raw data, analyzed as a data for a particular asset. So it tells me when it was first discovered, and if I look in the workflows, this is the more interesting part to me, because it kind of shows you the steps, selecting using the LLM to select the tool, running the API query, getting the data, formatting the data, and then transmitting the data through the LLM for interpretation. Let me run another question. So the platform is aimed to be a security partner that you can advise from, that you can ask questions, and you have discussions with your own data. That's, to me, the most relevant part. Okay, no assets. Okay, this is the last one but I have here an example where it played nicer with me. Right, when I asked it about a particular host, it gave me all the information collected from the host, ports open, service open, etc. So this is how it would look like. Now, I'm going to hand over back to Darius to continue the demo on Arcana side.
All right, so let's see. This is Arcana's UI. Right now I have two use cases in there. The one we'll look at is this one, vulnerability management decision model. The general data flow will be input via REST API. Then we'll have our decision. And based on the decision, we'll trigger one of those agentic workflows. And finally, we could send a Slack message to notify the stakeholders. As I said, these models are trained manually. So that means I had to select the fields in the alert body that are relevant for the decision. After that, I had to label examples and train the model on those examples until it started predicting very well on new scenarios and on new documents. This particular model was trained on around 92 alerts, 92 different documents, and we have a few decision options. Either we remediate with blocking a firewall port or creating a WAF rule, we trigger an investigation, or we archive the case. So at this point, the accuracy is 96%, and that's counted on the new findings after the training. This is generally what we aim for on any type of data set, over 90-95% accuracy on new scenarios. Now, we have 4 agentic workflows, and each one of them has to do something else. Before I show you some runs from each of them, just so you understand what these are, this is basically Python code. It's based on Google's Agent Development Kit open source framework. And we essentially define the agents there, give them their instructions, what model they should use, and also what tools they should use. And when I say tools, I mean MCP tooling. We have a bunch of different MCP servers in the platform, like Elastic, Splunk, Arcana itself, ServiceNow, VirusTotal. But in these workflows, we'll be using the NoSQL MCP server. Now, I won't dive any deeper into the actual code, but let's look at some examples. Starting with the investigation one. From NoSQL, we got something that was discovered on the dark web, mentioning an IP from that enterprise's network, mentioning that it had a public Jenkins console available and that he's planning to exploit it. And of course, the first step is we need to make sure that we actually have that vulnerability. So starting from this initial JSON file, the first agent has to parse the relevant asset. It will then do an MCP call to get the assets available in the platform, cross-check them, find the relevant ones. And it did find some matches. And now from those matches, we could derive the actual asset ID in the database. And we did a get risk by asset call for this as well to see any other risks that may be present on that particular host. So this actually confirmed that indeed there is an instance available with an available console, which would allow remote code execution. It's very easy to exploit due to that. There are some security headers missing, and there's also a GitHub repo available on port 80, where we could see that we have some environment variable files which have secrets, so not good. Now that it was validated, we get all these findings and send them again to the decision model to update the case and make it able to send a notification to the relevant teams. And to make it more, let's say, easy to digest, we also have a last agent that will do a nice HTML report with the finding, the information that was found related to that, and technical details of the risks and vulnerabilities associated with the hosts, the steps taken from the workflow, some recommendations, and the conclusion. And this could be delivered as well, as this whole workflow would be fully automated, and only when response cannot be automated, it would go to the team to actually do it. So this would be the case where we run an investigation. Something easier would be, in this case, where we have some, the scanner received an HTTP response saying that SQL syntax was incorrect, which means that form or whatever was on that page is vulnerable to SQL injection. The model figured out that the best course of action is to respond on the WAF by adding a rule to block any requests that contain SQL syntax in them. This is a more straightforward decision that could be done. That can be validated, and if everything's fine, move on. Same thing in case we have something like an exposed Docker API, which shouldn't be exposed. We can train the model that in this case, it should send a request to block that port, don't expose it to the internet. This is more like a misconfiguration, but it can lead to some problems as well. So this is another type of decision. Now, the interesting thing is, you could, in theory, set deterministic rules to do these kinds of response, but the problem is, if it's too dynamic and too varied, the environment changes, it's hard to maintain, and for any new thing, it will not work. Then if you choose to do this with an LLM by itself, for this one, which should be archived, the LLM would have disposed an actual response. Because in this case, we have an advisory from Jenkins for a DOS vulnerability, but it's actually irrelevant in this case because the instances are only used internally for internal use, and DOS is not that much relevant. So in this case, the decision model just archived it and sent a notification with the archival note of what this is about to the stakeholders. But here we have full control to train these models according to what we expect from them in our environment. We don't want the internet bias that are in the large models, so decision-making should be kept very strict. And yeah, this pretty much wraps this part of the demo. And yeah, you can take it back.
All right, one last slide. So if there is anything that we would want to make sure that you leave this presentation with, right? A typical loop, right? You detect, you have visibility, and then you have a report or a human that makes a decision. Now, with AI, agentic AI workflows, and machine learning-based decision models, you you still have human in the loop up until you get the model trained to a confident level, but then you can fully automate from detection to response, and you just inform the analyst. And I think with that, we wrap up. We are open to questions.
All right.
I have a few questions in the room already. If you have
Yes, one of my colleagues is going to bring you a microphone just in a moment. There. Summer, can you please raise the hand again? Thanks.
Thank you for your presentation. Is it possible to connect Arcana AI to CM or XOR for developing playbooks on it?
Yes, thank you for the question. Yes, we actually usually connect to the SIM or to the SOR. Those are our two main data sources. We want to be where the analyst is when starting the investigation or decision-making process. So yes, and we integrate with most SIMs and most SORs. Thank you.
Thank you.
And another question in the third row. Yes.
Hello. I want to ask also, you said that you need to train Arcana, right, in order to make decision afterwards. But how much time do you need to train? Because in this demo, for example, we had about 4 scenarios, right? But we can have a lot more. So how much time we need to train to cover, let's say, 90% of all the possible scenarios? Is it feasible to use it? Do you have a way, for example, to ingest information from threat intelligence reports, something like that, which can explain, okay, you have this vulnerability, these might be some solutions that you can implement, and that will be a little bit easier, or only manual? Thank you.
Thank you for the question. So as to how much it takes to train the models, we generally train models. The first models that we train are for triaging the security alerts, wherever they come from, right? EDR firewall, web application firewall, and so on. There you don't have too many labels in reality. It's either a true positive or a false positive, or maybe with some caveats. So the number of labels is not insane. We've done use cases with 10, 12, 15 labels, depending on the process. But usually you switch to another model for another process. And you could have 20 models, each with different labels for different use cases. In terms of time, it's not about time, it's about the data sets that you have. So we generally get your historical data, let's say 6 months worth of data, and we group them by the decision points. So only what matters is relevant from that whole alert body. They're not actually unique. If you have 1 million alerts, there may be 3,000 unique ones. And those are the representatives. And we label, let's say, a quarter of those, train the model, and see how it reacts on the rest. And we go through this iterative phase, and we track the performance of the models across these training sessions. And we stop when we reach the desired accuracy, and then just maintain it. So it's about how much data you have, how varied it is, and the quality of your feedback, if it's consistent or not. And threat intel and anything that goes into making a decision, we can take it in the platform and take that into account as well.
All right, thank you very much. Are there any questions? Yes, and we still have time to take them, so.
Hello. So in the Arcana demo, in the remediation advisories, we've seen an accurate advisory based on the type of the vulnerability that was detected or presented. Is Arcana designed to integrate, in order to collect data about organizational security context, existing controls already in place, like existing firewall rules and existing WAF configuration, so that it maybe throw some of the vulnerabilities as not affected, or?
Not directly. So we don't have a plug-and-play solution that will connect and gather everything. But for that specific use case, we have the technical features to be able to go and fetch that data and take that into account when reviewing whether a vulnerability is useful or not. That would count as a decision point.
Okay, like for example, if I had, you said it integrates natively with most of the SIEMs. If I had Splunk as a SIEM, but also in the Splunk module, I had all the firewall rules and the WAF configuration data, Arcana can read from that and apply in the engine to decide whether remediation is already done or not, or?
Yes, exactly. If it's available in Splunk, yes.
Okay, thank you.
Yeah, I think just to add on top of that, I think you can consider creating MPCP servers for different data sources, and then you're going to have agentic workflows to go fetch the data on demand.
Yeah, that would actually be easier.
All right. Any other questions? I think that we had a few more in the back there, and we will get another question.
Thank you. So first of all, very nice, complex presentation. I want to piggyback off the previous question about training Arcana, but it's more for how do you set up and ensure that you have the right context in RAG? What sort of data would you include to be relevant to your use cases so it doesn't hallucinate and it stays on point? And this is for RAG training, either one of you.
Go first.
So Arcana's decision models are not related to LLMs.
Oh.
And we don't use RAG. You control exactly what fields in the JSON you use for training, and you label the data yourself. And that's how the intuition and your knowledge goes into the model. So it doesn't hallucinate, only if you trained it wrong. And we have a consensus mechanism where the entire team can train on the same data and will take the majority decision to avoid even team inconsistencies. But because of this, we are separated from how you would train an LLM, which does have the issues you mentioned.
Yeah, so for node synthesis, it uses a RAG. The way that which data is decided to go into RAG, that's static. We have static rules if then else. If it meets the bar, if the risk is high enough, then that data goes into the RAG. We don't want to pollute RAG, therefore the chat conversation will be skewed. So there's a static decision what goes into the RAG, but then it's the LLM itself and its accuracy into deciding which is the most relevant information for the particular conversation.
Okay, I understand. And for setting up the RAG database for the specific security use cases you described, how would you go about doing that?
Well, in this particular case, it was about vulnerability scanning. So looking at CVSS scoring, looking at CVE information, those are decision making. So if it contains SQL injection, if it contains 9.8 CVSS scoring, things like that, static things, those are the decision based through which the data goes into the RAG and therefore accessible for the chatbot.
Okay, thank you.
Yeah,
very good answer.
That's a good question. I just wanted to add that it is indeed a very tricky decision on how to put data into the RAG, especially when you have large documents. You need to trim it. You need to make sure that your split area kind of overlaps a bit, at least 50% of the sentences that goes in. So there's a bit of mastery there, but you can definitely. And of course, you need to remove the headers and the footnotes. Those mess up RAG. Yeah.
All right, amazing questions. Are there any other? 2 questions there, and then I'm coming back to you. Thanks.
Thank you. I got a question regarding the risk detection. I was wondering if you also handle the risk management of other MCP servers or tools. So do you detect potential risk or maybe vulnerabilities in other MCP servers or tools?
Was that a question for me or for Arcana? Or which, do you know?
Any of you.
So in OSINTEL, we only integrate, so we have a built-in MCP server that only allows you to have conversations with OSINTEL itself, data sources. But I think that's easily extendable to other sources. You just need to connect it to other servers. I think it's totally doable. We can take it offline, but at the moment, we don't have that. But I think it can be up for debate, yeah.
Okay.
But if you want to add anything on that, I think we're good.
Okay, thank you so much.
Thank you for the question.
All right. Exactly.
Hey, thank you for the demo. That was really cool. I have a question about the LLMs that you use. Are you using them as they come out of the box? Are you performing some fine-tuning on them or something else? And also, if you can tell me, which models did you find to work best at cybersecurity tasks like these ones?
I think the sound was a bit low.
I heard it.
You heard the question?
Yeah, I heard the question. Thank you. So it depends on the use cases and the actual requirements and compliance aspects. Ideally, you'd want to use like a Claude Sonnet, latest one. That's the best if you want to do use cases like this one. AWS through Bedrock promises they don't do anything with your data, so you have that. However, for people that want on-prem deployments and they want their own LLM hosted locally on their GPUs, generally the out-of-the-box models that you have are not good enough, and there you have to do fine-tuning to get them workable. So Llama 3 or GPT OSS 120B, you still need to fine-tune those to get some value out of them. The frontier models, not so much. They work very well with RAG and MCP, and they deal with a lot of context, so they work better.
Thank you for adding the on-prem part. That's really helpful.
All right, thank you very much. And we are going to take the last question from here, from the front row. Thank you for the extended Q&A. It's very helpful.
Yeah.
Hello, and thank you for the presentation. I would like to ask you, at the beginning you were mentioning the agent, the AI, is being trained manually. Does it still learn while being deployed in production? And does bad prompting affects the usability in the long run?
So it will always be garbage in, garbage out with any kind of models. With the decision models, which are more similar to convolutional neural networks, you have better control on how you train them. You can spot if you have inconsistencies, so if you change your mind on similar things, we show you that. We have guardrails to make sure that what you put in is good and you're fine with it. It can also be changed at any point in time. So if the policy changed, if you realized you made a mistake, if something changes, you can go back and modify the knowledge base, retrain the model to have the updated knowledge. With LLMs, you have to be very careful with the prompts. But we like to validate the result of the LLM with a decision model to make sure it fits the pattern of output that we expect as a guardrail. But with LLMs, you really need to be careful with the prompts. It's better to even split them in separate agents, control very well the input and an output of every step. And if you do it right, and trial and error, and thousands of testing times, it can work.
Okay, so if it helps me solve a problem, and the next time if I want to solve another similar task, should I be training again the model, or does it already know the solution it applied the first time?
Yeah, so for the decision model, whatever comes new will be approximated to something closer to something in the knowledge base. The closer it is to something, the higher the confidence that that's the correct decision, so it will work on any new data.
Thank you.
And statistically, based on the accuracy and F1 score you have for that particular model, that's the likelihood of you getting the correct or wrong decision. And you have to say, okay, I'm fine with this risk acceptance. It's 98% accurate on new scenario. The old scenarios are 100%, and most mistakes are actually, maybe it's more conservative. It's telling you it's true positive, if it's not. You don't want it the other way around to drop your true positives, right? So you can control the bias of the model through training and decide when you accept the risk of letting it run.
Thank you.